So these questions here can be a wee bit tricky, but just with practice you should be able to get them. Okay, so this is a June 2015 SEA Double Award Science Physics paper. So it gives us a circuit, and it says the current flowing through the 4 ohms resistor is 0.3 amps. What currents flow through the other 2 resistors? Okay, now just to go over our rules about current and voltage and things like that, because you do need to know them. So this is obviously series. So in a series circuit, the current is the same everywhere. So the current here at A1 is equal to the current at A2 is equal to the current at A3. Now, a series circuit is just where there's one path of electricity flow around. So the current anywhere on that series circuit is the same. Okay. Then if we look at the parallel part here, okay, so in a parallel circuit, the total current is equal to the sum of the individual branch currents. So a branch is where, where you get to a point in the circuit and you have more than one path to go down. So this is a branch and this is a branch. So if we looked at here, so A1, that was our starting current or whatever, A1 should equal to A2 plus A3. And then they'll join together and give you A4. So A1 and A4 are the same, and A2 plus A3 should give us A1, and A2 plus A3 should give us A4, because they're the same. So going back to this example, so it says what is the current in these 2 resistors. So it says that's a series, and it tells us that the current flowing through that is 0.3. We know a current in a series stays the same everywhere. This one here, because it's parallel, the current is going to split. So the 0.3 is going to split in 2. So the current going across this resistor and this resistor should, added together, should give us 0.3. Okay, so if we write down our formula that links resistance, voltage and current, we have I equals V over R, voltage, resistance, current. Now looking at the formula, as our resistance gets bigger, our current should then get smaller. So before you do anything, just looking at this formula, you should know that when the resistance is bigger, current is smaller, so therefore we should be getting a smaller current value going through this 6 ohms. So the first thing I'm going to do is find the total voltage through the circuit. Okay, I can use this formula here. V is equal to IR. So we obviously have to find the resistance of these 2 here, that's parallel. So using your 1 over RT formula. So it's 1 over 3 plus 1 over 6. So that's 1 over RT, RT is just flip that upside down, so the resistance of this bit here is 2 ohms. So the total resistance is 4 plus 2 is 6, so I'm going to write RT is equal to 6, and the current is 0.3. So using this equation, we have 0.3 times 6. Which is 1.8. Okay, so that's the total voltage. Now going through here, and because this part's series, so you know that the voltage is going to split, so the voltage across this isn't going to be the 1.8. So work out what the voltage is for here. So V is equal to IR again. It's 4 to resistance times 0.3, which equals to 1.2. So when we've got to here, this point here, the voltage we have left is 1.8, take away 1.2, which equals to 0.6. Okay, so that is our voltage, and in a parallel circuit the voltage is the same. So using this equation, I have my voltage of 0.6 divided by my first resistance is 3. Okay, which equals to 0.2. Because the current across this one and this one are going to add together to give me 0.3, I can just do 0.3, take away 0.2, which will give me this one to be 0.1. You can go and substitute in the formula if you want, so it's our voltage again is the same in parallel, so it's 0.6 divided by 6, which equals to 0.1, which is what we found out.